Number 106, referring to example 23.14, find the average power at 10 kilohertz. All right, so to find the average power, we first have to work with the average power formula, right? And this is going to be equal to the root mean square current multiplied by the root mean square voltage multiplied by the cosine of the phase angle. So let's read it. So our LC circuit has this resistance, this inductance, this capacitance, and a voltage source with a root mean square of 120, right? So I already noticed that I'm going to do a substitution because I already have my root mean square voltage. So I noticed that in this formula that the root mean square current is equal to this. So I'm going to take it and I'm going to plug it in. Okay. So once I do that and simplify it, it becomes this. V sub R mass squared, because now there's two voltages, you're squaring it, and then divided them by the impedance, multiplied by the cosine then of the phase angle. All right. And now I notice here, right, I have a little relationship over here between phase angle now and the impedance. All right. So now, yeah, why don't we do that? They didn't really tell. Yeah. So what I'm going to now do is I'm going to do this substitution. Okay. I'm going to take this because it's equal to the cosine of the phase angle, and I'm going to substitute it. Right. So now what happens is we get something that looks like this. P average is going to be equal to root mean square voltage divided by Z multiplied now by R over Z. So this now works out to be P average is equal to basically V over Z squared, okay, times R. That's basically what it's going to work out to be. Depends on how you want to simplify it and whatnot. Yeah, it might be easier to, I don't know. I don't think it really makes a difference. So this is going to be V over Z. This whole thing will be squared then. Multiply that then by R. Okay, so we know the root mean square voltage, it's 120. We know the resistance, it's 40. But what we don't know is the impedance. So that's what we have to solve. We have to solve it using this formula. I'm not going to substitute it all into this formula because it's going to become a mess. So I'm just going to start doing it here. That the impedance here will be equal to the square root of R. So that is going to be 40 ohms. Not the square, well, the square root of R squared, right? So 40 squared plus then the difference now between the reactive capacitance and the reactive inductance right in here. Now they didn't tell it to me, so I got to do a quick calculation. So the reactive inductance is going to be 2 pi. We remember this formulas from before. Frequency times the inductance. So this is basically going to be 2 pi times the frequency. What was the frequency? What did they tell us? Voltage source with that, calculate the power factor. Good, at 60 hertz. So we're going to have to be using 60 hertz, okay? What is the average power? Actually, find the average power at, no, I'm sorry. I got to refer back to this one now. 10 kilohertz, okay? 10 kilohertz. So that's going to be 10 times 10 to the third. And the impedance here they told us is going to be 3 millihenry. So that's going to be 3 times 10 to the minus 3. These 10s will basically cancel each other out. So X sub L will then be 2 times pi. So 2 times pi times then 10 times 3. So there's about 188.5. All right, ohms. So this is 188.5. Then minus now the reactive capacitance. So now we got to do X sub C is 1 over now 2 pi times the frequency times the capacitance. 1 over now 2 pi times the 10 times 10 to the third. Then by the capacitance, and where is that here? A 5 microfarad, right? So that's going to be, I'm running out of space, but that's going to be 5 times 10 to the minus 6, okay, because it's micro. So then let's just do the work out. So this is going to be 1 divided by now parenthesis 2 pi times then 10 times 10 to the third times 5 times 10 to the minus 6th. Close the parentheses. We get about 3.18. All right, so X sub C is about 3.18 ohms. We plug that in, 3.18. We take the difference and then we're going to square it. So this is now the square root of 40 squared plus now parenthesis. That exact answer, 188.49, blah, blah, blah. Minus then the exact answer, 3.18.09, blah, blah, blah. Close the parentheses and square it. So we get a whole Z value here of about 189.6. Take that now and plug it on in, okay? And we got everything we need. So now this is going to simply be 120 volts squared, divided then by the 189.6. Well, let me not square that yet. Let's just do that division. Squared, and then multiply that by the resistance of 40 ohms. Okay, so we'll take 120, divide it by that exact answer, square that result, and then multiply that by 40. So about 16.0 watts. All right, and that is then the power. Guys, thanks for tuning in. This chapter was a doozy, and hopefully the chapters aren't that bad. We'll see. I'll see you in the next one, guys. Take it easy.